Hi again, class. Now we're going to look at one of the features on a weather map that is pretty prominent, and those are called fronts. And we're first going to look at cold fronts. We're going to get into cold fronts and warm fronts in much greater detail in Chapter 10. But for now, I'm just trying to get you used to what's on a surface weather map. And cold fronts are one of those prominent features because it's usually a big weather maker. And so a cold front appears on a weather map as a solid line, solid blue line with blue triangles pointing into the direction that the front is moving. Okay, so if we're going to look at this in 3 dimensions, it will look something like this. Oh, I'm going to write over my stuff there. So behind the cold front, you're going to find colder and drier air. And so this is typically air that's coming out of Canada. If you want to say we're importing it from Canada, you can think of it that way. Being colder and drier, this is going to be more dense air. And density differences are going to be huge in terms of weather. And so the air behind the cold front is colder, drier, and more denser. That's good. That's just more dense. And it is moving in the direction, the triangles are pointing into the direction that the front is moving. So in this particular case, colder, drier, more dense air is moving from left to right across the page. And again, this is probably being imported from Canada. So out ahead of the cold front, by definition, is an air mass that is going to be relatively warmer and moister. And being relatively warmer and moister, this air is going to be less dense. And so again, the densities here are going to be pretty critical in our discussion of fronts. Okay, so the cold front itself, or fronts in general, but we'll talk about cold fronts more specifically here. So cold fronts are boundaries that separate air masses that have different densities. And those different densities are going to be a function of the temperature and the moisture content of those air masses. Okay, so in this particular case, the cold dry air is doing the advancing. That's why we call it a cold front. So a cold front, the cold dry air is doing the advancing. It's moving into that warm, moist air. Okay. Now, these air masses that have different densities, they don't mix well because of those different densities. An example would be if you go to the grocery store and you're looking for Italian salad dressing, the oil and vinegar type. If you look at the bottle and you take it off the shelf, you notice that the oil is floating on top of the vinegar. And that's because oil and vinegar have different densities. The oil is less dense, it's going to float to the top. The vinegar is more dense, and so it settles to the bottom. So if you go to the grocery store and you look for meteorological salad dressing, and you pull the bottle off the shelf, the cold, dry air is going to settle to the bottom, and the warm, moist air is going to rise to the top because the warm, moist air is less dense. Okay, and so with a cold front, then that cold, dry air, as it advances, cold, dry air, as it advances, it's being denser. Will wedge its way under that warm, moist air. Okay. Now, we talked about low pressure systems. Convergence in the center of low pressure was important because that convergence, when the air converges counterclockwise and inward in the center of low pressure, it has to rise. Rising air is going to carry water vapor up into the air. Here is another way in which air is forced to rise. We call this frontal wedging. Okay, and frontal wedging is important. Frontal wedging will force air to rise. And as that air rises, the water vapor will be carried up into the atmosphere. Okay, so now with water vapor being carried up into the atmosphere, we have the possibility for clouds and precipitation. And so this frontal wedging, forcing air to rise, carrying water vapor up into the atmosphere, this is often going to result in the rising air. Okay. And as a result of that, clouds and precipitation. And cold fronts are particularly important. You got a fairly steep, steeply sloped front here. And so cold fronts, if you're talking about severe weather, cold fronts are more associated with, so I'll write down possibly associated with cold fronts, possibly associated with thunderstorms. So if we come over here, so we got the colder, drier air doing the advancing into the warmer, moister air. That's going to force this warm, moist air to rise. As the air rises, you can form clouds, and again, because they're more associated with cold fronts, I'll draw thunderstorm clouds here. So here you got some more warm, moist air being forced to rise. And so here we got some thunderstorms forming. I'll draw another one down here. Cloud base, you get that thunderstorm cloud forming. And so you'll find that with cold fronts, the clouds and precipitation associated with cold fronts let my hand catch up to my mouth here for a second. So with cold fronts, the clouds and precipitation associated with cold fronts are usually in close proximity to the front. Get this over a little. All right. So, yeah, cold fronts are interesting features on a weather map. They're typically weather makers, and so we pay really close attention to them in meteorology. And so this gives you a little better idea than how, I shouldn't say how they develop, but gives you an idea that once they're developed, what they look like and how they act and what they mean in terms of weather. All right, so the next thing we're going to do is take a look at warm fronts. That's coming up next.